Okay, now that we're pretty confident with the basics of vectors, we can actually look to use those basic skills and ideas to help us solve some more complex problems. And one of the really key ideas that we need to be familiar with is explained in this first box that we've got here. So essentially, we can see some different vectors marked on there, and they're kind of topping and tailing our vectors A and B. So we can see that our vector A on that grid looks like it moves 2 to the right and 3 up. So let's start by writing that vector down. So vector A is moving 2 to the right and then 3 up. And our vector B, we can see from the grid, it's moving to the right quite a lot. It's moving 1, 2, 3, 4, 5, 6, 7. And it's also moving up by 2. Now what we're going to do is just add the two vectors together in the same way that we did previously. So we're going to take vector A, add on vector B, and just do it with the numbers first of all. So we've got this 2, 3, and we're going to add on the 7, 2. So we've got a movement of 2 to the right, then another 7 to the right. That is a movement of 9 to the right. And then on the y-axis, a movement of 3 up, and then another 2 up is 5 up in total. But if you actually have a look at the vector A plus B on the diagram, you will notice we still start and finish in the same place. Let me put a little dot where it starts. So it starts bottom left there. Vector A plus B finishes top right there. And if we actually count that movement that we've done to get there, we can see it's 1, 2, 3, 4, 5, 6, 7, 8, 9 to the right. And how many up is it? 1, 2, 3, 4, 5. And if you have a look at what we got from the two vectors that we added together, our A plus B, that's exactly what happened. We ended up with a vector of 9, 5. So what this first example is showing us here is that it doesn't matter what path you take. So when we went just along vector A and then along vector B, we could see it was a longer path to take, but we still started and finished in the same place as our vector A plus B moved, which is a more direct line. So that idea is going to be really, really key. We can take any path that we want with our vectors, as long as we start and end in the same place. Once we simplify all the vectors down, we'll still end up with the same numbers, just like the 9, 5 that we got there. So let's see if we can use that idea to help us solve a slightly more complex problem. So this next example says that we have some sort of trapezium, PQRS, and along with vectors A, 3B, and 9B. And it also says that M is the midpoint of QR. So we've got some key information in there that is going to help us. First of all, the fact we've got trapezium, you might start to think about some facts that you know to do with trapezium. So you've got one pair of parallel sides there. And also the fact that M is a midpoint is going to be really key as well. And the first thing that we're going to try and work out is the vector SQ, and we're just going to write it in terms of our A and B. So essentially it's just saying, how do you get from a start position of S to a finish position of Q? So S we can see here is bottom left, and then Q is on this top right part over here. So we do want to try, if we can, to move directly along that in a straight line. But of course, that purple line that I've just drawn on there, we don't know what that vector is in terms of A and B. But remember the idea that we just discussed in the previous example. It doesn't matter which path you take with vectors, as long as you're starting and finishing at that same point. So what we can do is just follow any path where we know the vectors. So what I could do first of all is start by moving up this path that we've got here. I'll just highlight that. And then we can move across to the right. So we're still finishing on point Q and starting on point S, but we've just taken a slightly different path, but it doesn't actually matter. So to go from our S to our Q, we've gone S to P first of all, and then we've gone from P to Q. So still starting and finishing in the same positions. And then we just write down what those missing parts are. So we know to get from S to P, that is simply vector A. We don't know it in column form, but that's fine. We're just going to write it like this. And then to get from P to Q, we know that that's 3B. And then we've answered the question. We have managed to write the vector S to Q in terms of vectors A and B. Next question that we've got, we're going to try and do the inverse. So we're going to go from Q to S. So we can imagine trying to start on Q, finishing down there on S, moving in that direction. Same idea as before, we want to try and move along that most direct path, but we don't know what those vectors are. So we choose any path that we can. So what we can do is start on Q and go to P first of all. So on the diagram, that's moving along in this direction. And then we're going to be moving down from there, going from P to S. This is just where you need to be really careful and look at which direction the arrows are pointing though. So to go from Q to P, I need to move back along that 3B. So it's actually going to be a minus 3B, first of all. And then we can see going from P to S, again, we're moving in the opposite direction of that arrow. So we're going to be doing a minus vector A there. Similar idea with the next one. We want to try and get from Q to R. Most direct way to do it is to go straight along Q to R, which would be moving along this line here, but we're not given any vectors on that path. So again, we need to try and find a path where we know all of the vectors. So it is a longer way to get there, but remember with the vectors, it doesn't matter which path you choose. So what we can do is actually move from Q to P, first of all. Then we could go P to S. And then finally, we could go S to R. And then we're just going to write down each of those parts. So Q to P we know is a minus 3B. Going to do it with the underscore instead this time, just to show you the different ways of writing these. We know P to S is a minus A. And finally, S to R is given as 9B. And we're moving in the positive direction of that, moving in the way the arrow is pointing. And then we can just collect like terms. So I've got a minus 3B, but then I'm going to add 9Bs onto that. So that's going to give me a positive 6B. And then there's no other A's to collect, so that minus A just stays the same. Final one that we've got here is going from Q to M. So again, we want to try and just move along that path that we've got there, but we don't know exactly how to do it. What we can do though, and this is very common in the exam, is you normally have to use a previous answer to help you with a following part. So to get from Q to M, we actually already know that M is the midpoint of Q to R. So all that we need to do is move halfway along how we get from Q to R. And if you look at the question that we just answered, we already know how to get from Q to R. So all that we need to do is take a half of that answer because we're moving half of the distance along it. So I'm going to take half of my 6B minus A from the previous part. And if we expand and simplify, we're going to have a 3B and we're going to subtract half an A.